Hi students, and welcome to the latest of the preliminary chemistry videos. This one also from the Chemical Earth, and today we're going to focus on ionic compounds and the formation of cations and anions. Here's a little diagram, I guess, just to show you some of the ways in which ions can form. The first of these is a sodium atom. Sodium has the electron configuration 2, 8, 1. And so it has just the one electron in its outer shell, and that's this one right here. When it combines with an atom of chlorine, which has the electron configuration 2, 8, and 7, it transfers that electron to the chlorine. In doing so, it loses the outer shell electron, and its configuration is now 2, 8. The loss of that one electron has given it an overall positive charge because now the number of protons is greater than the number of electrons. For the chlorine, the reverse has happened. An extra electron means that it now has a configuration of 2, 8, 8. As a consequence, it has a negative charge, and this is because the number of electrons is greater than the number of protons. So the extra electron has come in, and we now have 18 electrons and only 17 protons, which gives it a negative charge. And for the sodium, we have 10 electrons and 11 protons, and hence we have a positive charge. When we look at the formation of something like sodium oxide, you can see that the electron configuration for the sodium is still 2, 8, 1 as it was before, but for the oxygen, it's 2, 6. Oxygen actually requires 2 electrons in order for it to become stable in its outer shell. But each individual sodium can only contribute the 1 electron, and therefore an oxygen atom requires 2 sodium atoms in order for it to fill its outer shell. That means 2 electrons will be added to the oxygen atom. This will produce an anion, an oxygen anion with a 2- charge. That will be balanced by 2 sodium ions, and they're cations, with positive charges. What it means is we have a formula of Na2O, and this represents the ratio of sodium to oxygen in this compound. When we look at the periodic table, and as I've mentioned to you before, you're always going to have this tool, so it's really important that you try as much as possible to put as many different labels as you can. The first group, the group 1 metals, or the active metals, have a 1+ charge. The alkaline earth metals have a +2 charge. The transition metals can have multiple charges and multiple valencies, and we've talked about that before as well. Most of them will have a 2+ charge and often a 2+ and some other charge, but that's not all of them, and there are lots and lots of different things that are happening with the transition metals. The third group has a +3. The fourth one is ±4, and we put it that way to kind of indicate that these ones don't tend to form ions as well. Some of the ones further down the bottom of the table are still metallic, and so therefore they will ionize, but the ones up the top will not. -3 for the next group, -2 for the group with oxygen at the top, and -1 for the halogens, the second last group on the table, and then the very last group, which are the noble gases, are the ones that do not combine at all. They are monatomic molecules because they don't form ions and they don't form compounds. The thing with ionic bonds is that we have to distinguish between 2 species that attract one another. That is, if the sodium transfers an electron to the chlorine, then the sodium will become positive and the chlorine will become negative. And we sort of tend to think about them as a pair. But in reality, this is more likely to be the case. Now, from this arrangement, you can see there's a single central negative charge, or anion, And this is surrounded by cations in effectively 3 dimensions. Doesn't quite look like that on the page, but effectively in 3 dimensions, in the plane in which it is sitting and then above and below that plane as well. These are the ways that ionic compounds actually grow in terms of their crystal structure, or their lattice that we also call it. They form an array because these particular alternating cations and anions can just continue to go on forever, and each of the bonds in between a cation and an anion is an ionic bond, and they're equally strong. Once the atom has become charged, once the atom has become an ion, and this is a cat and this is an an, then they are a source of positive or negative charge, and so they will therefore attract any oppositely charged objects around them in all of the dimensions. So can you explain the formation of a cation and an anion? The cation is a positive ion. I'll just change the color there. It's a positive ion, and therefore it forms when a species, an atom or a group of atoms, loses 1 or more electrons. And this will produce a positively charged particle, or a cation. An anion is a negative ion, and as a result it forms when a species gains 1 or more electrons. This sort of terminology is very important to add to your lexicon in chemistry, because being able to use terms like cation and anion are very important when you're answering questions. Thanks for watching.